Hello and welcome to today's lesson. In today's lesson, we'll look at oxides of carbon. Okay, we have been looking at carbon. We've looked at the allotropes of carbon. Today, we want to look at what? The oxides of carbon. Now, because carbon exhibits a valency of what? 2 and what? 4. It is able to bond with oxygen in 2 ways. Okay, and this oxides is what we want to look at today. The 2 oxides that carbon form with oxygen are called carbon monoxide and then carbon dioxide, which is also called carbon 2 oxide and carbon 4 oxide. Now, if you look at my right, you will see carbon dioxide there. This is a Lewis structure. It's telling you that it has no lone pair of what? Electron. Okay, while carbon monoxide has 1 lone pair of what? Electron in the carbon atom. I'm talking about in respect to the carbon atom. You can see it now. Okay, for carbon monoxide, you can see the triple bond telling you there are 3 bond pair and 1 lone pair of what? Electron. We'll first of all look at carbon dioxide. Carbon dioxide is found in the atmosphere in a very small amount, okay, 0.03%, okay, and in the combined state it is found in calcium hydrogen triisocarbonate 4 and also calcium carbonate, which is called limestone. In the laboratory, carbon 4 oxide is prepared by the action of dilute acid on marble chip or calcium carbonate. Dilute acid such as HCl or HNO3 on triisocarbonate 4 or calcium hydrogen triisocarbonate 4 substance. In this process, calcium carbonate is first placed inside a round bottom flask fitted with a tensile funnel connected by a glass tube. The glass tube will allow the delivery of the gas, which can be collected by a glass jar. Okay, now what you do is you now add your dilute HCl or HNO3 into the calcium carbonate, and then you, of course, you will witness effervescence, and then the gas will follow this connecting tube to the glass jar. Okay, this of course is the way we obtain carbon 4 oxide in the laboratory. After obtaining the gas, you can now test for the property of the gas. Of course, carbon 4 oxide is colorless, some are odorless, and some few have sharp smell. Here's the equation for the reaction. Of course, you can also use other metallic carbonate, exception of sodium and potassium, because those are very, very stable. You need high amount of heat to break it down. As you can see here, you can use sodium hydrogen triisocarbonate 4. Of course, it will decompose and still give you carbon 4 oxide. But take note, those of sodium and potassium are not used because they are very stable. This diagram is called the Gibbs apparatus. Okay, it allows us to obtain carbon 4 oxide from the laboratory at any time it is needed. Okay, it consists of marble chips and dilute hydrochloric acid. So every time the jar is opened, the gas is collected as the reaction occur. The CO2 can sometimes be collected over water. Okay, we can also get carbon 4 oxide in the industry as a byproduct during fermentation process. Of course, you know fermentation is catalyzed by enzymes such as your Z-mase and the rest. Okay, you can see the reaction in this process. Carbon 4 oxide is giving us as a byproduct. Let's now look at some of the properties of carbon 4 oxide. Okay, carbon 4 oxide, of course, you know, is a colorless and odorless gas, although some might have a sharp smell. Okay, it has a very refreshing taste when you drink it, as in we call it sparkling water or you call soda water. All right, it is about 1.5 times heavier or denser than air. This is one of the reasons why it extinguishes fire. When cool, it solidifies. Okay, and it's also soluble in water. In fact, when it dissolves with water, it forms an acid which we call a dibasic acid called triisocarbonate 4 acid. Okay, when we say dibasic, we mean we have 2 replaceable hydrogen ion. Okay, and this dissociation, because it's weak, does not take place once. Okay, it first of all dissociates to form hydrogen triisocarbonate 4 ion, and then before it now dissociates completely to form the carbonate 4 ion. Okay, in large water bodies, the carbonic ions dissociation is quite or slightly different. It forms what we call a bicarbonate ion, that is 2 carbonate ion will be formed in water. So this will now delay or reduce the formation of its main constituent called calcite, okay, or should I say it slow the process of the formation of calcite, because it's not forming a what? Acid, is it not? Yes. Carbon 4 oxide also reacts directly with an alkali to produce a triazocarbonate 4 salt, okay, which of course is a basic salt. But with plentiful supply of CO2, sodium hydrogen triazocarbonate 4 is formed. Now, sodium carbonate salt can be either anhydrous or anhydrate. Take note of that, okay? Alkali solution readily absorbs carbon 4 oxide. Because of this, it is used to remove carbon 4 oxide when it is not needed in certain reactions. Okay, reaction with burning magnesium. When burning magnesium combines with carbon 4 oxide, it does not burn, okay, because carbon 4 oxide does not support what? Combustion. Instead, what you have is a white deposit of carbon and magnesium oxide formed in the what? Process. This is because carbon 4 oxide does not support what? Combustion. All right. But when CO2 is passed through red hot carbon, okay, the CO2 will be reduced from carbon 4 oxide to carbon 2 oxide. Okay, how can we test for carbon 4 oxide? We can test for carbon 4 oxide by using what? Lime water, what you know as calcium what? Hydroxide. Okay, the action of the gas on calcium hydroxide, we turn the lime water milky, that is cloudy, because of the formation of calcium hydrogen triazocarbonate 4, okay, and then on excess of the lime water, it will dissolve, confirming the presence of carbon 4 oxide, okay. The reaction is as a result of the formation of calcium carbonate. Take note of that. Uses of carbon 4 oxide. Carbon 4 oxide is very useful because it does not support combustion. It is used extensively as what? Fire extinguisher. Remember I said when it is cool, it solidifies, what you call white ice. Yes, because of this, its inability to support combustion, it is used as a fire extinguisher. It is also used to give drinks refreshing what? Taste. Okay, we also use it for the production of sodium carbonate and sodium hydrogen triazocarbonate 4. We use it for the production of lead 2 carbonate and the synthesis of urea and ammonium sulfate, which are very important material for the synthesis of fertilizers. Supercritical carbon 4 oxide, which is a carbon 4 oxide that is subjected to a temperature above STP, is very useful. Okay, it is used to extract certain materials because it does not damage them. Let's now look at the other oxides. Okay, the other oxide known as carbon 2 oxide or carbon monoxide. Carbon 2 oxide is produced as a result of the incomplete combustion of some carbon compound like octane in oxygen. Okay, trace amount of it is found as impurity in the atmosphere. Okay, you must also know that carbon monoxide is a very poisonous gas. Okay, if a small percentage of it is found in your system, it will bond with your hemoglobin. Okay, and this will reduce the supply of oxygen, which causes death in patients. In the laboratory, we prepare carbon monoxide by dehydrating either oxalic acid, which is also called ethane dioic acid, or formic acid, which is also called methanoic acid, with conc tetrasulfate acid. This actually results in the formation of both carbon 4 oxide and carbon 2 oxide in the case of ethane dioic acid. Therefore, as you can see in this diagram, the mixture will be passed through either potassium hydroxide or sodium hydroxide, which will help to absorb all the carbon 4 oxide, leaving only the carbon 2 oxide to be collected over water. Because carbon monoxide is very poisonous, the preparation process is done in a fume cupboard, okay, to prevent accidents that will lead to death, because the gas is colorless, you can't see it. We can also prepare carbon 2 oxide or carbon monoxide from carbon 4 oxide by allowing it to pass through red hot coke or charcoal. As you can see in this process, still small amount of or small trace of carbon 4 oxide will also accompany the carbon 2 oxide. Those ones that they were not reduced, take note. So you have to pass it through that same sodium hydroxide or potassium hydroxide. All right, collect your pure gas over water. Let's now look at the properties of carbon monoxide. Carbon monoxide is a colorless, odorless, and tasteless gas. Okay,
It is insoluble in water, but it dissolves in ammonium copper 2 chloride. Carbon monoxide, it's slightly less dense than air, that is less heavier than air. It is what? Neutral to litmus paper. Chemically, it acts as a strong reducing agent, okay? It reduces lead 2 oxide to give you what? Lead, while it itself is what? Oxidized to what? Carbon 4 oxide. It also does that with iodine pentaoxide, okay? It reduces iodine pentaoxide into iodine, while itself is oxidized into 5 moles of what? Carbon 4 oxide. What about water? It's also a formation of a water gas, which you already know, is it not? Yes. Carbon monoxide also undergo combination reaction, okay? It combines directly with what? Oxygen to produce carbon 4 oxide. It burns with a blue flame. This reaction is always done with a faint blue flame, okay? Take note of it. Like I said earlier, it combines with what? Hemoglobin, is it not? In your blood system, which will reduce the supply of oxygen to your brain and lead to what? Death of a victim eventually. Let's now look at the uses, okay? Carbon monoxide is used as a reducing agent to extract metals from their what? Ore. It is also used as a constituent in syngas, which of course is a combination of water gas and what producer gas, obtained by the gasification process of coke. I think you still remember, yes. One thing you must know here is that water gas is considered a better fare than producer gas because it contains less nitrogen and it burns with a lot of what? Energy. It gives off a lot of energy. Unlike producer gas that has a high volume of nitrogen, okay? But although producer gas is very, very what? Cheap compared to water gas. That now brings us to the end of today's lesson. Remember to do other activities in this class. I'll see you soon. Bye.